Good day, everyone. In this exercise, we have a piston cylinder assembly. We have a 1 kilogram of liquid water at 20 degrees Celsius and 300 kilopascal. Heat is added, and the pressure became 600 kilopascal. The question also states that the maximum value of the volume could be when the piston reaches the stoppers. If this is the case, the volume will be 0.002 meter cube. But how can we tell if we are at the maximum volume or not? A hint was given that the final pressure is 600 kilopascal. We know in a piston cylinder assembly that the pressure will remain constant as long as the piston is moving up while the heat is being added. However, when they mention that the pressure is now doubled, this can tell us that the piston has really stopped somewhere at the stopper, and the pressure started to increase above 300 all the way to 600. So now we know for sure that the piston has stopped at the stoppers. So we can write the following states. So we have state number 1. We have a pressure of 300 kilopascal. We have a temperature of 20 degrees Celsius, and we are not sure about its volume. We have state 2. We know for sure that this is where the pressure is still 300. However, we know that the volume 2 is maximum, which is the volume at the stop, and it is 0.002 meter cube. As for temperature 2, we don't know. Later, we know that the pressure increased all the way to 600 kilopascal. We don't know about the temperature, but we also know that volume 3 is actually the same as volume 2. This is why the piston is actually stuck to the stoppers upward. So, what is the final volume? So, for part 1, V final is the V at the stopper, which is 0.002 meter cube as given. Part 2, what is the work? Now, in order to see the work involved here between 1 and 3, it's better to plot the PV diagram to visualize what's happening. So this is the pressure versus volume. We know very well that we are adding heat and volume is expanding, but we know very well as well that the pressure remains constant until the piston hits the stoppers. So our state, say number 1 is here. We are increasing the volume until we reach state number 2, and this is happening at pressure number 1. Then when the piston reaches the stoppers, the pressure starts to build up at a constant volume. So we can know that we are going vertically upward at a constant volume. Now the work produced here is due to the volume expansion as the heat is added. So the work is the area under this part. The work between 2 and 3 is 0 because the volume is constant. And if you are wondering how we produce work, remember that we have been adding heat to the process. So writing now the work between state 1 and 3 is the work between state 1 and 2 plus the work between 2 and 3. Now we know this is 0 because V volume is constant. We can write this as pressure 1, volume 2 minus volume 1. Or, in another way, we can re-express this as mass specific volume 2 minus specific volume 1. We have the mass already, and if we can find the specific volumes, then we can work out the work. So let's find specific volume 1. If you go to table B11 at 20 degrees Celsius, at 20 degrees Celsius, you will find that the pressure, saturation pressure, is 2.339 kilopascal. This is smaller than our existing pressure. In this case, we know that we are in the compressed liquid, which is B14. If you go to B14, and if you look at our values, you will find that there is no 300 kilopascal and we don't have the data. In this case, it's a good estimation to go and check the liquid specific volume at 20 degrees Celsius using the B1.1 tables. So if we go back up to B11, you will find that at 20 degrees Celsius, 0.001002 is our value, or our closest value that can be used with minimal error. So our PSAT here was found as 2.339. It is smaller than P1, which is 300 kilopascal. We knew we are in the compressed liquid region. Hence, we went to table B14. We found no data at 20 degrees Celsius and 300 Pascal. So we have estimated our value using table B11. We can say specific volume 1 can be estimated as specific volume of the liquid at 20 degrees Celsius. Remember, it's always the estimation at the temperature, not the pressure. Equals to 0.001002 meter cube per kilogram. Now we have found V1. What is specific volume V2? We know from the given that volume 2 is the volume at the stoppers, which is here. That's the volume at the stoppers, which is 0.002, and we know the mass given in the question as 1 kilogram. We know mass is 1 kilogram. It's a closed system, and we should have expressed previously that our system is taken as such. So we know that masses are equal. In this case, specific volume 2 is equal to 0.002. Now we can work out the work as the mass, which is 1 kilogram, multiplied by our P1, multiplied by the difference in volumes, specific volumes. And the work output is 0.3 kilojoule. State number 2, where the specific volume is 0.002 at 20 degrees Celsius, is a mixture of water and vapor. You can go over the table B11 and you can check that the specific volume is within the V sub F and V sub G. If you would like to draw then the diagram fully, as shown above, you may find that the dome is somehow looking like so. This is where we start with 1 as compressed liquid. We go into the saturated mixture of water and vapor, and then we go up to state number 3.